Hi, in this video we will demonstrate an open source project called ztachip. Ztachip is a fully open source. It is a fully stack AI accelerated solution. So it's covering all the way from chip design to software to compiler to Python today. So in this picture here, we're going to show you the architecture of ztachip running an AI agent at the edge, right? So you see here that we have the Zeta chip on a chip. So this chip here can be like a programmable chip like FPGA, or it could be like an ASIC. So on the Zeta chip, we should be able to run the LLM model. So LLM is the latest AI technology today, like the kind of technology that power ChatGPT. So it will be able to do reasoning, planning, understanding human language, understanding vision. So very important. So this is like a critical piece of technology today. So we'll show it you later. Like ztachip is capable of running the LLM model. Then you got the CNN task. So CNN is more like like an older AI technology, but it's very fast. So it's complementary the LLM. For example, like if you want to analyze the some sensor information, so CNN is really good for that. It's kind of very smart pattern matching. So that's what it's good for. So you do need CNN for AI edge devices. And then it handle a bunch of other stuff like vision, like image resizing, uh, color conversion from the camera, motion detection. So standard um, vision processing task. And then you got system task because ztachip is running MicroPython as the OS. So it can do like many of the system tasks, and then you can pull in some of other open source uh, project that was designed for MicroPython to be integrated with ztachip. Yeah, so here we take care of the transformer model, CNN model, and then a lot of like data transfer. So you can see here, it run MicroPython, right? So it can talk to sensor. This is the kind of application that you could use: home automation, industrial monitoring, smart IoT, and then it can connect to MQT Wi-Fi because the Zeta chip is running on MicroPython. Though MicroPython is a lightweight version of Python, that running on an embedded device, very small, very compact. So it support a lot of these like back-end communication that you can use. And then, you can hook up to display purposes. So this is how we envision like the edge devices running Zeta chip. Okay, so now we're going to show you the a demo of how this actually worked, right? Okay, so this is uh the development kit that we use to uh to run ztachip today, and also to do the development. So if you can see here, we're using a special chip. They call it FPGA. So this is a programmable chip. So once you got like a chip design, you program to it at runtime. So building like a custom chip is it's time, take a lot of time, take a lot of money. So this is a very good way to prototype your chip, or in many cases, it's fast enough. Like this is a very low end chip. Like you can see, there's no heatsink, and it's very cost effective. I think believe this chip here you can get it for like $30, And then here's the memory. So on these devices here, it's only got 256 megabyte of memory, like very low end, right? So like Raspberry Pi, for example, they got like gigabyte. Here you just have 256 megabyte. So here we demonstrate that AI agent running on a very resource constrained hardware. And this has got the Adreno Shield. So this is an excellent platform, like for you to, prototype your hardware, make sure it works before you build your own hardware, right? So the internal shield here, you can buy different kind of shield on the market, and then here it connect to a camera, right? And then the VGA, and then it connect back to the PC over the USB cable. Here's the Ethernet. So this is like to download the large language model. And this is like for serial interface. So this is a development kit. Like it's not a final product. So it's good for prototype. And it's good for you, like if you're doing AI research, it's excellent for it. Okay, so let's doing the presentation. So we're going to show you like the different capabilities of ztachip, right? So let's go back to the PC. Okay, so on the laptop here, I got like the serial port console to ztachip. So this is running MicroPython. So this is a console to the MicroPython. So let's pick some examples. So the first example I'm going to show you is running the transformer, the chatbot. So to show you that ztachip is capable of handle the latest AI model, right? The transformer model. So this is like a key model today. So I'm going to just cut and paste this. MicroPython, very easy. You don't have to like rebuild anything. You just like type in the code, right? And then, so here it start to download the model. So this is going to take like a couple minutes. So I just fast forward here. Okay, so we already download the model to ztachip. So now it's running a chatbot, right? So you can try it out a few questions like what is the capital of Canada? Capital Canada is Ottawa. Good. What is the capital of France? Okay. So it understands the human language and also the human knowledge. So right now on this demo here, I just show you the text input, right? But on the future demo, it also will understand the video. So you'll be able to ask questions about what do you see on the camera? Do you see an accident on a camera, or do you see an elderly uh, in trouble, right? So that would be good, like for like a video camera application. So let's ask another one. Who is Albert Einstein? So the speed here is roughly about almost the speed of a Raspberry Pi 4, but this board here has less than 10% of the hardware resources as a Raspberry, but yet it's almost have the same performance like Raspberry Pi 4. So this is good because it showed that the accelerator help you to get the most out of your hardware. Okay, so this demo here, actually, this is probably not used for edge devices, right? Because this is a chatbot application. But here we demonstrate the the capabilities of the LLM architecture that is supported by ztachip. So I'm going to give you another demo that is more relevant for AI Edge. So I'm going to stop this one by pressing the one button here. Okay, so we're going to go back to the laptop, right? So let's go back to the laptop, and we're going to go back to the serial console. So we're going to paste another application. So this one here is, I call it LLM function calling. So with LLM function calling, so instead of chatbot, the LLM is talking to Python. So it take your request, your intent, and tell the Python what function to call, because one of the key function of AI agent is that it taking actions, right? So for edge devices, typically you don't have a lot of memory, so you have to run on small model. So the way to do it is you're running a fine-tuned model to keep the model small but yet still smart. So in this one here, I did fine-tune the base model from Hugging Face, and then make it understand IoT commands like turn on, turn off the lights. But you can fine tune to anything you want. Like it's based on LoRa framework, so it's pretty flexible. Okay, so I cut and paste this. So to get the MicroPython the program, then I just hit Control E to put it in paste mode. Paste my code, and there you go. So now it's going to download like another model, like a fine-tuned model, specifically fine-tuned for a particular hardware capability, hardware design, like to control your peripherals or whatever. So this is going to take a few minutes, so I'm going to just fast forward. So you can see here that is downloading the model. So I'll just fast forward here. Okay, so the model is loaded. So we download like a fine-tuned model um, that will understand how to turn on and off the light, right? So we just want to keep it nice and simple for now. So I'm going to issue a request. Turn on the LED. And then you're going to see it respond. The response back is the Python function call, right? Let on. So in this case here, it's not talking to human, but it's talking back to the machine. And the machine, in this case, my Python, is going to call the appropriate function to turn on the LED. So now AI can take actions, right? It's not just a chatbot, but taking action. So it understands the human language. Like, let's say that you misspell a little bit, it still understand it. I put like a 2N on the on, still understand. So, oh, please turn off. Now instead of LED, I call light. So turn it off. You're going to see the LED here. Turn off. Let's have another syntax. LED on, please. So I just on purpose misspell it a little bit. So you can see the light now turn back on. Okay, so this is like a typical case for embedded device. So AI taking actions on your hardware. And uh, I'm fine tuning it using like an open source framework called LoRa. So you can fine tune it to your own custom hardware and go any way you want. So it's very easy to do. Okay, so we finished with the let on the LLM demo. So now let's move on to other type of accelerations, right? So I'm going to stop this, press a button. Okay, so now I'm going to go back to my laptop. Okay, so let's try a different application, because as we show on the first picture, that beside LLM, it has to handle like a different kind of acceleration. So let's say the CNN model. So image classification, this is a very important class of AI applications. So I'm going to cut and paste this to my MicroPython console. Control E to put in paste mode, paste the code, Control D to execute. Okay, now we're going to go back to the ztachip, right? So you're going to see that the image classification working, right? So it can recognize objects. So you see a coffee mug. So you see coffee mug, 70% a score, and yeah. So this kind of AI application is very important because, for example, like you may use this kind of model to detect some sensor input. Like for example, like you want to analyze the input from the motors, right? To see if there's something wrong with the motors. Very important class of application, CNN model. Okay, so let's move on to another application. So I stop this one here. Now I'm going to go back to the Python. Okay, so the next one is going to be the big one, right? Because now we're going to show like how everything works together. Because on the AI agents, you need all of these things working at the same time. Vision CNN LLM example. So this one here will show you LLM, a bunch of vision tasks, edge detection, uh, a point of interest, optical flow to detect motion, a CNN model to do object detection, and all at the same time, right? Under MicroPython. So MicroPython is only like to launch the program actually. So most of acceleration is happening in FPGA. Okay, so the same thing, right? So now I'm going to paste the code. Okay, Control D. Now it's going to download like the fine-tuned model again to turn on and off the light using LLM model. So I'm going to just fast forward here because the downloading will take like about 2 minutes. Okay, so the model is downloaded. So here you got 5 different applications running at the same time. Okay, so on this model here, on this screen here, so we're doing the object detection, right? So let's see, detect the cup here. Okay, so we see the cup, multi-object detection. So this is a CNN model. So this is an important class of application. And then on the screen here, we do edge detection. So you see it keep up with, it's still, even if we're running all 5 applications, it still keep up with mostly with the camera input. So here is the point of interest. So see, it finds some landmark on this picture for a video stabilizer. And here's a motion detector. So see, if I move the camera, it detects the motions. Okay, so now, so this is similar to the last demo, actually, if you saw it. But the big difference now is actually we got a 5th application also running at the same time. So at the bottom here, you're going to see the LLM prompt. So here I'm running the fine-tuned model to control the light, right? Okay, so I'm going to do the same thing. Turn on the light, please. Right? So now, because I'm running like 5 different things, so things get slowed down a little bit. But if we spawn in reasonable amount of time, so we spawn back the Python function to do it. So this is instead of like a chatbot, though actually it's talk to the machine. So it's just have different syntax here, like it would understand it. Let off. So you see the light here will turn off. Yeah, that's it. Okay, so this kind of demonstrate to you all the different capabilities it needs to build modern AI agents at the edge. So AI agent is the future, right? So it's going to be everywhere. So I hope that you find this video useful. So I invite you to read some of the documents on the GitHub page. So it will go over some of the hardware architecture, design. Um, so in terms of the future roadmap, so the immediate um, release, we're going to take care of the multimodal support for LLM. So that means that in a future demo here, you would be able to ask questions like, what do you see, right? That is like extremely useful. Or do you see an accident? Stuff like this. So it would be extremely useful for like a video camera applications. So yeah, like check back in a few months and maybe I'll have the demo for that by then. Okay, thank you for your time. That's it. Thank you.